welcome to our first day of e-learning. So remember, we have decided to switch units for the time being. I think for our first week of e-learning, it's best to work on something you're going to be a little more familiar with. Factoring is something a lot of people struggle with. And so we're going to switch gears to our blue packets, which is Unit 11. This is a mini unit on radicals. So we're going to go ahead and begin with that because it's already something you're a little bit familiar with. So go ahead and open up your notes and find day one here. What we're going to do today is we will go through our notes. We're going to cut a couple problems, and then I will be telling you what homework you're doing on worksheet 1. We are not going to do the whole worksheet. We're going to do just, about half-ish of the problems, I would say. And then you're also going to take a 4 to 5 question Canvas quiz. And this Canvas quiz will give me an idea of how you're doing with this material. And you can take it an unlimited number of times. Okay, you can take it as many times as you would like. And then you're going to submit your homework through the assignment tab on Canvas. I can show you where that is right now. Hold that thought. So your page should look something like this. You're going to take your Canvas quiz check-in after this video, then you're going to do your homework, make sure you check your answers, and then click here to submit your worksheet. If you have any questions on worksheet 1, you can click on here and you can go ahead and, this is a discussion tab, you can let me know if you have any questions. But of course you can also email me or Canvas message me. I will be on my computer all day, so I'm just an email or message away. All right, let's go ahead and let's get started on our video. So we're going to start by reminding you of how perfect squares work. Remember, perfect squares are ones you should have memorized. They do not require a factor tree, and they do not have a root when we're done. So square root of 25, we should just be able to look at that and know that it's 5. Square root of 100, we should be able to look at that and know that it's a 10, but this time with a negative out front. 2/3 root 9. Well, start with your root 9. Root 9 is just 3. And then we'll do 3 times 2/3. 2 times 3 is 6, divided by 3 is 2. All right, let's try this one. We can't divide these right now because one has a root and one doesn't, but this we can evaluate. Root 100 is just 10, divided by 5 is 2. And these are all ones we should be able to do without a calculator. All right, finally, root 16 is 4, times root 4 is 2. 4 times 2 is 8. And our last one, go ahead and see if you can do this one. It should just be 5 over 2. All right, there you go. That's your perfect square recap. Let's come down to remembering how to simplify radicals using factor trees. All right, we aren't going to do all of these. Let's just do... Let's do 1 through 4. And of course our initial example here. So remember, what we're going to do with factor trees is we'll break down our number with whichever numbers you would want. So I'm going to use 4 and 3. And then we'll keep breaking down our numbers. 4 becomes 2 and 2. You are looking for pairs. So I have a pair of 2's. I'm going to circle, cross out. The 3 does not have a pair, so I'm underlining it. Remember, we don't care about the 4 because the 4 broke down further. We just care about the ones that can't break down anymore. And then 2 root 3 would be our answer. Remember, underlines go under the root. All right, so let's give that a shot with these 4. 48, any numbers you want will work. I'm going to do 8 and 6. 8 becomes 4 and 2. 4 becomes 2 and 2. 6 becomes 2 and 3. So again, we're only looking at what's at the bottom, and we have a pair of 2's, circle, cross out, another pair of 2's, circle, cross out. We'll underline our 3. Remember, underlines go under the root, and remember what we do with our circles? We multiply them. 2 times 2 is 4. All right, let's try it again. 72. So here's a trick that I showed you guys before. 72, I know, is 36 times 2. The reason I use 36 is because 36 is 6 times 6. It's a perfect square. Now, yes, the 6's can break down further. However, I have a pair of them right now, so I'm not going to break them down more. I'm just going to leave them as a pair. circle a 6, cross out a 6, underline my 2, because again 2 does not have a buddy, and this just becomes 6 root 2. Okay. All right, now what's different about 21? When we break down 21, we just get 7 and 3. You can't break either of those down further, and they don't have a pair. So we'll underline both of those. They'll remultiply and go back under the root. This is really just root 21 again. This is already simplified. There's nothing that you can do with it. All right, and then one more like this before we go on to the new stuff. So notice there's a number out front here. We are going to have to do something with that at the end, but for right now, we'll just go ahead and we'll break down our tree here. So 125 is just 25 times 5, and then 25 is 5 times 5. So I have a pair of 5s, circle, cross out. This 5 doesn't have anybody, very sad. So that's a 5 root 5. And be careful because a bunch of you would leave it like this, especially when we have multiple choice. So be careful about that. There is still a 4 out front. Just getting this ready for later. So we're going to multiply by that 4. 4 times 5 is 20. All right, so that took about 5 minutes or so to explain those problems. That was your review from what we did just a couple weeks ago, actually. So now I'm going to teach you something new. I'm going to teach you how to multiply radicals. This is one of our new skills today. The new skills are multiplying radicals, and then we will also work with variables under radicals. Those are the 2 new skills. So when we're multiplying radicals, numbers under the root can multiply together. So root 2 times root 3 is just root 6. But the really big thing we have to be careful about is when we have something like this. We're going to multiply the outside number by the outside number. So 4 and 5 would be your outside numbers here. 4 times 5 is 20. And then we're going to multiply the inside number by the inside number. Okay, so 2 times 5, or root 2 times root 5 is root 10. Okay, and then you should try to do a tree, but root 10, notice, would be kind of like root 21. You won't have any pairs, so it would just be that as your final answer. All right, let's flip it. Let's try 5 of these. Okay, so again, first step, outside times outside. 3 times 4 is 12. Inside times inside. Root 5 times root 2 is root 10. Check if you can do a tree only with the radical. That doesn't do anything, so 12 root 10 is our answer. Okay. Let's try another one. 1/2 times, this would be a 1, is 1/2. So that was outside times outside, inside times inside. 6 times 12 is 72. Now 72 we can for sure break down. Okay, before I use 36 and 2, I'm just going to do that again. Again, the benefit of using a perfect square is that then you get these automatic pairs. So I'm going to go circle a 6, cross out a 6. My 2 doesn't have a buddy, it gets underlined. So now be careful about what we talked about up here. Oops, right here. Don't forget about that number up front. So it's not just 6 root 2. It's 6 root 2 times 1/2, and 1/2 times 6 is 3 root 2. Okay, let's try it again. Outside times the outside. 7 times 3 is 21. Root inside times the inside. 8 times 3 is 24. Don't worry about the 21. Worry about what's under the root. Is that something we can break down? Well, yeah, it is. So I'm going to do 12 and 2. 12 is 6 and 2. 6 is 3 and 2. I have a pair of 2's. Circle, cross out. The 3 and 2 don't have anybody. They get underlined. So the root 24 is going to be a 2 root 6. Notice I just multiplied those two together, but then I'm multiplying by that 21 that's still out front there. So that's going to be a 42 root 6. Okay. All right, two more. These are a little different. Let's see why. Outside times the outside. 5 times 1 is 5. Root inside times the inside. 20 times 5 is 100. All right, stop and look at that for a minute. What do you notice? What do I want you to notice? If you said perfect square, you are correct. Square root of 100 is a perfect square. There is no need to do a factor tree. Square root of 100 is just 10. You're multiplying by 5. 5 times 10 is 50. Do not tell me this is 5 root 10. No, 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 no. Root 100 is perfect. It loses the root. Okay, so it just becomes 10. All right, last one like this. Then we'll talk about our second skill, working with variables under radicals. Outside times the outside. 1/3 times 1 is 1/3. Inside times the inside. Root 9 times root 9 is root 81. But what do you notice again? Know your perfect squares. Root 81 is just 9. Okay, bring down your 1/3. 1/3 times 9. 1 times 9, 9. Divide by 3, 3. All right, very good. Last thing we're going to talk about today is working with variables under the radicals. All right, now these look a little scary, but I promise they're not too bad. They're actually pretty fast, and some people prefer them to dealing with our factor trees. So basically, here's how this works. If it's square root of g squared means there are 2 g's, right? You can even make a little tree if you want. Okay. So it's a square root. We're looking for pairs, just like before. You have a pair of g's. Circle, cross out. Okay, nothing got underlined, so we just bring the g out from under the root, and g is your answer. Okay, let's try it again. G squared, that's g and g. F squared, f and f. What do we have a pair of? We have a pair of g's, circle, cross out. We have a pair of f's, circle, cross out. Circles come out, so our answer is just GF. All right. Let's put a number in there. Square root of 4. All right, well, square root of 4, that's a perfect square. We should just know the answer to that. Square root of 4 is 2. No root over it. It's a perfect square. M squared, m times m. You got a pair of m's. Circle, cross out. So an m comes out as well. All right, let's see what happens when we don't have an exponent of 2. All of those had an exponent that was squared. So let's try this one. Square root of 16, m to the 4th. Okay. Well, the square root of 16, you should know in your head. Square root of 16 is 4. M to the 4th. Okay. This would be 4 m's. We're looking for pairs. How many you got? You have 2. Circle, cross out. Circle, cross out. So we're not going to bring out an m this time. We're going to bring out an m squared. Let's do a few more of these, see if you can figure out the pattern. M to the 6th. How many m's would that be? If you said 6, you are correct. You're looking for pairs. How many pairs are there? There are 3 of them. So, what's our answer? M to the 3rd. M to the 8th. How many m's is that? If you said 8, you are correct. We're looking for pairs. How many pairs do you have? We have 4 of them. What's your answer going to be? M to the 4th. All right, last one. I think at this point you probably have figured out the rule. M to the 10th. How many m's are there? There are 10. All right, I'm going to write them all out. 6, 7, 8, 9, 10. Okay, I'm looking for pairs. How many pairs are there? There are going to be 5. So our answer is m to the 5th. So what that means, guys, what you should notice here is that you have 6 m's or 10 m's. It's always half of them that are pairs, right? Like if you have 20 pairs of shoes, that's really 40 shoes altogether. All that's happening here is we're taking how many m's there are and we're dividing it by 2 because that's how many pairs there would be. So if I told you m to the 1,000th, square root of m to the 1,000th, you don't want to draw 1,000 m's. That would be madness. Who wants to do that? Instead, we can just say, oh, well, there are 1,000 m's, so there would be 500 pairs. M to the 500th. That would be my answer. Okay? Easy peasy. That's when we have an even exponent. Now, when we have an odd exponent, it gets a little dicier, okay? I don't want you to say this is m to the 3.5. No, no, no. Okay? Go back and think about what you do with perfects or with factor trees. Let's write out my 7m's. There's 7, right? I'm still looking for pairs. Circle, cross out, circle, cross out, circle, cross out. What did we do before when we didn't have a pair? We underlined it. So we have 3 m's that are coming out, m to the 3rd. This guy didn't have anybody. It stayed under the root. Underlines go under the root. Okay, so when you have an odd exponent, there's always going to be one guy that's left over. Oh, I shouldn't circle him. I'll just highlight him. One guy that's left over that's going to be underneath the root. It's only going to be one. Only one can be left over. Because if it was 2 left over, that's a pair, and pairs can always come out. Okay, so take a look. Here's how we do this one. You're going to treat the k and the g separately. The g is easy. It's an even. There are 8 g's. How many pairs would there be? 4. So g to the 4th is going to come out. The k, there are 9 of them. Okay, so if I have 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so look, if we go ahead and we circle, cross out, circle, cross out, circle, cross out, circle, cross out, this k's all by itself, he's going to get underlined. How many k's were circled? There were 4 of them. So 4 come out, but then this k was underlined, so he goes under the root. All right, it's that easy. Your evens, we're going to divide the exponent by 2. Our odds, we'll leave 1 inside, and we'll divide the rest by 2. Okay, so like, for example, if you had square root of g to the 11th, here's how I'm going to look at it. 11 is an odd. 1g is going to be left inside. I took care of him. Now I'm down to 10 g's. There are 5 pairs. So g to the 5th would come out. Okay. All right, let's do 10 and 11. We are going to skip 12. I'm going to try to keep this video 20 minutes. So number 10, let's run through here. K is an odd. Leave a k inside. Now you're down to 12. How many pairs are there? 6. Bring a k to the 6th out. Okay. J to the 12th, that's even. Even, we just divide by 2. J to the 6th comes out. G to the 17th, that's odd. Leave a g inside. That's the one that doesn't have a pair. Now you're down to 16. If you have 16 g's, you have 8 pairs. 8 come out. That's your answer. Last one for today. You've been great for your first e-learning lesson. Regular numbers, well, we can take the square root of 16. It's just 4. Okay, so your numbers treat as normal. M to the 12th, it's an even. Divide by 2. M to the 6th. R to the 11th, it's an odd. Odds, leave 1 inside. Now we're down to 10. How many pairs are there? 5. Bring out R to the 5th. G to the 8th, it's an even. 8 divided by 2, 4 pairs. Bring it out. The only ones that stay inside are the ones that do not have pairs. Okay? All right, fantastic. So what you're going to do next, just as a reminder, you are going to go ahead and I would do your Canvas quiz check-in right now. Okay? And then you should start working on homework. Homework. You probably want to know what we're going to cut. So how about I tell you? Find your worksheet 1. It's in your other blue packet. Okay? So here's what I want you to do. You are going to do 1 to 12. Okay. 1 to 12. So all of those guys. Flip the page. Whoops. Apparently got to delete some of that. Okay, so you're doing 1 to 12. You are going to do 18, 19, 21, 25, 26, 27. Notice I'm taking out some of the ones with bigger numbers here. Okay, so again, that's 1 to 12, 18, 19, 21, 25, 26, 27. Those are the problems that you are responsible for doing. Okay, so once you do those, you want to check your answers, which I gave to you, that's on a blue sheet, but they're also here, and then you're going to click to submit your worksheet. Okay, you can either do this on your Chromebook and take a picture of it, or you can do this with the app on your phone. Okay, if you can't figure it out, please message me. You can always take a picture of it and email it to me as well. That would be fine. Okay, so again, your responsibilities are do the homework that I just told you, submit it, and do your Canvas quiz. Okay, and I hope you have a wonderful day. Check in tomorrow. We will be moving on to day 2. See you later. Bye.